Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello students, welcome again to the TV learning programs. This is Teacher Pasco, and today I will be learning chemistry with Senior 2 students. In unit number 1 of Senior 2, you discussed the formation of different bonds, chemical bonds. And one of the bonds you learned is ionic bonding. What is ionic bonding? How is it formed? And what are some of the properties of the compounds formed with an ionic bonding? That will be the focus of us today to help us start the new unit, unit number 6, which is preparation of salts and identification of ions. Now, let us start with a revision exercise. How can you separate the components of the following mixtures? Water and salt. Ethanol and water. And number 2, state any 2 physical properties of ionic compounds. You have 1 minute to think about those 2 questions. Hope you're done. Now let us answer the first question. The mixture we have is a mixture of water and salt. Salt is an ionic compound which is soluble in water, and it gives a clear solution. How can we separate the 2 components of our mixture? We can use evaporation if we don't want to collect water, and we can also use simple distillation if we want to collect water. So we have 2 possible answers: evaporation if you don't want to collect water, and simple distillation if you want to collect water. How can we separate the components of a mixture of ethanol and water? Ethanol and water are 2 liquids which are totally miscible, but they have very different boiling points. And because of that, we can separate them by using simple distillation. So we use simple distillation. Question number 2, state any 2 physical properties of ionic compounds. Ionic compounds have so many physical properties, and here we can list high melting and boiling points. Number 2, they are soluble in water. I will not list all of the physical properties, but if you don't remember all of them, you can go back to unit number 1. I hope you have so many details about the physical properties. Now let us focus on this property number 2. Ionic compounds are soluble in water. And today's unit, the unit we are starting today, is the preparation of salts. Before we go any further, can anyone suggest a definition of a salt? Try to think about what a salt is. What is a salt? We know the common salt, the table salt we use in the kitchen. But here we are saying preparation of salts. So there are many. So what is the meaning of salt? So all ionic compounds, all those compounds containing ionic bonds which can dissolve in water to make clear solutions, they are salts. So a simple definition of a salt is that a salt is an ionic compound. But then what do they form when they dissolve in water? They form solutions. The salts, which are ionic compounds, dissolve in water to form solutions, and the solutions are making our today's topic. So the title of our today's lesson is salts. We have different types of salts, and today we will analyze how the different salts can be prepared and the differences and the similarities between those different salts. But before that, let us define what a salt is, what a solution is. What is a solution? Good. A simple definition of a solution is given as a mixture of a solute and a solvent. And here, I want to carry out a simple and short demonstration, and you will tell me what component of the mixture will be a solute and what component will be a solvent, so as to give us our solution. Here we have a solid substance, an ionic substance, and that one is copper sulfate. This is solid copper sulfate. You can see it with the blue color. So we have copper sulfate, which is solid, and with a blue color. And here we have water, tap water. What do we get when we mix this water and the copper we have here? think about what we will get. What do we get? Now we have a solution. And a solution has two components. We said that a solution is a mixture of a solute and a solvent. In the solution we have here, we have a solute and a solvent. And I want you to identify which component. Remember, we have two components. We have copper sulfate, which has been dissolved, and we have water. Which of the two is the solute and which one of the two is the solvent? Hint. A solute is the substance which is present in a small amount or a smaller quantity. And the solvent is always present in a bigger quantity. So which one of the two is a solute? Which one of the two is a solvent? We have copper sulfate mixed with water, which is liquid, to give us a solution. And copper sulfate, because it is the one which is present in a smaller amount, then it is the one which is the solute. And water is good, the solvent, the one which is present in a bigger amount. So we have a solute which mixes with a solvent to give us a solution. We have different types of solutions. And before we go to those different types of solutions, let us have a short summary of the necessary definitions that you need to always remember. What is a solution? It is a homogeneous mixture of a solute. It can be one solute or many solutes, and a solvent. It is exactly the same as this one. And what is a solute? A solute is the substance which is dissolved in another substance. The other substance I'm talking about is the solvent. So a solute is that substance which is dissolved in another substance. And this other substance is the one we call a solvent. In a solution, a solute is always present in a smaller amount. That is clear. And what is a solvent now? A solvent is a substance in which a solute is dissolved. If we go back to our example, the demonstration, then we used water. Water is the solvent, the one which is present in a bigger amount, bigger quantity. And the other one which has been dissolved in that water is the solute. So the solvent here is a substance in which a solute will be dissolved. And in any solution, a solvent is always present in bigger quantity. The examples, if you take some table salt and dissolve that in water, the table salt will be the solute and water will be the solvent, while the mixture will be the solution. If you take 1 milliliter of hydrochloric acid and dissolve it in 100 milliliters of water, HCl, hydrochloric acid, which is present in a smaller amount, will be the solute, while water will be the solvent, and the whole mixture will be the solution. Here I have used different examples to show you that it is possible to have a solid solute or have a liquid solute. And it is also possible to have a gaseous solute. Clear? Now, let us have a look at the different types of solutions. Here we have our solution, the solution we have prepared, composed by copper sulfate and water. What happens? We have added a small amount of copper sulfate. What happens if we add more copper sulfate? What do you think will happen? Let us have a look. If we add more copper sulfate and mix, what happens? The copper sulfate will dissolve. It gradually dissolves. But do you think it will continue to be like that if we go on adding more and more and more solute, adding more copper sulfate? At a given point, the copper sulfate will no longer dissolve in the solution. And because of that, we get two types of solutions. A solution which can dissolve more solute if you add it, and a solution which cannot dissolve more solute. And from there, I said, we get two types. The two types are the unsaturated and saturated solution. Unsaturated and saturated solution. If you take a solution which is saturated and you add more solute, the solute you add will not dissolve because your solution has already dissolved the maximum amount of solute it can dissolve at a given temperature, at that temperature, the temperature under which you are working. So if we continue adding more and more copper sulfate in this solution, the solution we have here, at a given point, this solution will no longer be able to dissolve more copper sulfate. And that solution, which cannot dissolve more solute, we call it a saturated solution. Saturated solution. A saturated solution is a solution that contains the maximum amount of solute it can completely dissolve at a given temperature. You have to be very careful with that temperature. Why? Because when you change temperature, the solubility will decrease or increase, depending on how you have changed the temperature. We'll look at that very soon. And now, what is this unsaturated solution? We said that if you take this solution, which doesn't contain the maximum amount of solute it can contain, you are able to add more solute. It's possible, and that solute will dissolve. So that solution is qualified as being unsaturated because you can add more solute. You add more solute, and the solute dissolves. So a solution which is unsaturated, it is a solution containing less solute than it can completely dissolve at a given temperature. I think everything is clear. At a given temperature, if you have a solution in which you can add more solute and it dissolves, that is an unsaturated solution. But if more solute can no longer dissolve, then that is a saturated solution. We have other characteristics of both solutions that we are also going to compare. If you add more solute, the solute will dissolve. in an unsaturated solution. But if you add more solute in a saturated solution, it will not dissolve. In an unsaturated solution, when you increase the temperature, it will dissolve more solute. Normally, when you increase temperature, you favor the dissolution of more solute. More solid can decompose in a solution if you increase temperature. So, what is unsaturated? The solution which is unsaturated, it can dissolve more solute. It will do so even when you increase temperature. That is something very clear. It makes sense. But what happens when a saturated solution experiences an increase in temperature? Remember, a saturated solution cannot dissolve more solute. But what will happen when you increase its temperature? If you increase its temperature, now it will be able to dissolve more solute. Because we have seen that as you increase temperature, you favor the dissolution or the decomposition, the dissociation of more solid in the solution. So if you increase temperature of a solution which is saturated, you will be favoring the dissociation of more solute. And then more solute will be dissolved in that solution, which has a higher temperature. Now, let us have a look at another type, the third type of these solutions, the supersaturated solution. A supersaturated solution. Here we said that when a saturated solution containing the maximum amount of solute that it can dissolve experiences an increase in temperature. If you increase the temperature of this saturated solution, the solution will be able to dissolve more solute. And if it dissolves more solute, will you go on and call it a saturated solution? No. Because it has dissolved more solute than what it can dissolve normally. So in that case, the name has to change, and it becomes a supersaturated solution. So a supersaturated solution is a solution which dissolves excess solute due to an increase in temperature. When you increase temperature, the solution can dissolve more solute. And when that solution will cool down, it will not immediately precipitate the excess solute. So in that case, the cool solution you have will be a supersaturated solution. But the supersaturated solution is not very stable. So any dust which may be introduced in that solution will cause the precipitation of the excess solute. So that is a supersaturated solution. It can only be prepared when the temperature is very high. Those are the main types of solutions, but there is another way of classifying solutions. Depending on the amount of solute a solution contains. Suppose that you have a tea in your cup and you add some sugar. And when you taste it, you find it to be very sugary than needed. It is more sugary than needed. How can you reduce that sugar? Remember, you cannot filtrate it because it has dissolved. The only thing you can do is to take more tea, which doesn't contain sugar, and you mix with the first one, which was very sugary. And in that case, you will increase the volume of tea while you have not changed the quantity of sugar you have used. And from there, we can distinguish two types of solutions. The two types of solutions we can distinguish here, they are a concentrated solution and dilute solution. A concentrated solution it contains more solute. For example, here we have this solution which has a given amount of solute, X amount of solute. What happens if I add more water? If I add more water, now I get a dilute solution from a concentrated solution. So a dilute solution has a small amount of solute in a given volume. But a concentrated solution has a big amount of solute in that volume, in the same volume. So when you can prepare a dilute solution from a concentrated solution, if you increase the volume of the solvent while you don't increase the amount of solute. I think everything is clear. Now, before we end our lesson, let us have some questions for homework.